a lot. My name's Andrew Wilson. Welcome to this webinar on hydrogen in the built environment. I'm Sector Manager for the Supply Chain Sustainability School in Scotland, but it's great to be presenting this event on behalf of the entire school's membership across the whole of the country. It's been a massive interest in the subject of hydrogen across our members and across our partners over the last few months. Clearly, there's a massive drive for decarbonisation in the built environment, and many people now understand how central hydrogen will be in accelerating the transition to a low and zero carbon environment. It's really good timing that we're doing this now because the government's about to publish its own hydrogen strategy, and hydrogen targets are included in the 10-point plan around the green industrial revolution, which the government has recently published. So a whole lot of interest. It's going to be a fantastic 90 minutes of information, all aspects of utilisation and development and the technologies behind the rollout of hydrogen across built environment, not just in homes, but obviously on commercial buildings as well, right across built environment, hospitality, leisure, schools, hospitals, etc. So there's a massive opportunity to roll out hydrogen at scale over the next few years for future generations. In terms of our agenda this morning, we've got a 90-minute webinar. So we've got a number of speakers. Tom, first of all, from the Energy Network Association, talking about gas goes green and setting the scene for the 10-point plan and the transformation of the gas network. We've got James Whitmore from Cadent, who are talking about high deploy, using hydrogen blending through that project, and talking about HyNet as well, which is a mix of hydrogen use and CCS, carbon capture and storage, to rapidly decarbonise. So James is going to talk about two projects, high deploy and HyNet. We've got Stella joining from Northern Gas Networks, talking about using existing infrastructure to distribute hydrogen, and talking about demonstration homes, which are planning to be built very soon in the northeast, which is great. So to get more information about those demonstration homes from Stella. We've got Joe Mitchell from SGN talking about the 100% H105 green hydrogen project, which is being rolled out in Scotland at the moment. So it'd be great to get more information from that pure green hydrogen project, which is being delivered by SGN. Ollie Lancaster from Wales and West is going to talk more about installation and retrofit in terms of heating systems to ensure large-scale deployment of hydrogen across homes. And last but not no means least, Lloyd from National Grid Gas Transmission is going to talk about high NTS, the National Transmission System, developing hydrogen distribution within the National Transmission System. So a lot to get through. Before I pass across to our first speaker, Tom, just a few very quick notes about the school. You'll all have accounts with the school. I'd encourage you to use it as much as possible to increase your learning across all aspects of sustainability. You can see a little bit of information on that slide in terms of what the school does. We engage and accelerate sustainability knowledge right across the supply chain. We provide a standard approach to measuring supply sustainability, performance. And we've got a whole suite of learning materials across different aspects of not just sustainability, but enabling issues around the subject of sustainability. So you can see some of the figures there in terms of our activity levels over the last year, which has been really, really pleasing to expand our activities over the last 12 months in spite of the pandemic. These are our partners who contribute and fund our work. The school is all about collaboration. So this event is a perfect demonstration of that. We've got clients and partners on the customer side of the industry, on the first tier contractor side of the industry, across infrastructure, homes, construction and facilities management. So this webinar is particularly of interest to all of those sectors, as hydrogen obviously taps into all of those elements of the built environment that we are working within. So I'd like now to introduce our first speaker, Thomas Collar from Energy Network Association, who's going to talk about gas goes green. So Tom, welcome, over to you.
Thanks, Andrew. Good morning, everybody. I'm very pleased to be able to join you today to discuss hydrogen. Thank you for the invitation. As Andrew said, I'm Tom Collar. I'm the program lead for Gas Goes Green at the Energy Networks Association. ENA represents the companies that own and operate the gas and electricity network infrastructure, transporting gas and electricity to UK and Ireland households and businesses. And Gas Goes Green is a joint initiative between ENA, National Grid, Cadent, Northern Gas Networks, SGN, and Wales and West Utilities. And it's a programme that's working together to deliver the changes necessary to transition the current gas network infrastructure that's transporting methane-based natural gas today to one that is ready and ultimately delivering net zero hydrogen and increased amounts of biomethane to meet the challenge of net zero in the future. And so the Gas Goes Green programme is doing this through technical, engineering, policy, regulatory, various studies that supplements and joins together the network's own trials and research that you'll hear more about today. So I want to kick things off really with an update on UK hydrogen policy. At the end of last year, it was a very busy time for energy and climate policy. Andrew mentioned that we had the Prime Minister's 10-point plan for a green industrial revolution. We also received the 6th carbon budget advice to government from the Committee on Climate Change. We had a national infrastructure strategy published, and the long-awaited government energy white paper came out just before the end of the year. And this policy and ultimately what's going to follow on the back of it this year has implications for house builders, for commercial contractors, for many of you on the line today, and the wider supply chain. So in terms of the specific developments for hydrogen and the gas networks, so on the Prime Minister's 10-point plan, that sets a target of 5 gigawatts of hydrogen production capacity by 2030, and for 1 gigawatt of hydrogen capacity by 2025. As well as production, there's a focus on users and on the use of hydrogen in homes. The plan sets out for all the testing for blending, so blends of up to 20% hydrogen, to be completed by 2023 to allow for blending of hydrogen into the gas distribution grid by that time. And James from Cadent will say a bit more about that later on. The Prime Minister's 10-point plan also sets the aim of creating a hydrogen neighbourhood, and that's a group of homes receiving 100% hydrogen supply by 2023. And then the plan also says, can we create a larger hydrogen village? So a larger trial by 2025, and then possibly look ahead to 2030 for a hydrogen town to commence. The plan also discusses hydrogen being used in the transport sector, and we should see this year an investment of 20 million to support deployment of hydrogen vehicles, particularly heavy goods vehicles and other low emission lorries as well. So the government's energy white paper firmed up many of those commitments in the 10-point plan, but it also confirmed that this year we should see the conclusion of business models for hydrogen production, following a couple of years of consultation to perfect what those look like. And we should also see a consultation later this year on hydrogen-ready appliances. And that's very important to enable the transition, or the view of the transition that the gas networks think should take place. Much like we had with HD-ready TVs, there's a view from the gas networks and many partners of ours that if we have appliances that are ready for hydrogen in people's homes, in people's businesses, then that can anticipate that later switch over to a hydrogen supply and provide that period of insulation before the switchover happens. Alongside this year, we should receive a hydrogen strategy, which will detail the government's view of how we transition to hydrogen. So we're expecting that and the details that will provide before the summer recess. And we have already seen this year the government's industrial decarbonisation strategy, and a transport decarbonisation plan is due in the next couple of months. There's a lot of policy developments, and really the takeaway, I think, is that there's a strong signal from government that it is supporting and very interested in hydrogen. And ultimately, there's a lot of work to do on the back of those commitments to crystallise what those ambition looks like and how to bring it into effect. It's sort of against that policy backdrop that the Gas Goes Green programme and the network's own Future of Energy flagship projects are taking place. So to sort of set the scene for the rest of the morning, I wanted to begin with the shared pathway that the gas networks have in place to deliver the emissions reductions that are required for the UK to meet its climate change targets. Now, the gas goes green pathway that you can see illustrated here is a balanced one. And this really means that we think there will be a range of different heating technologies in that net zero energy future, that there will be different vehicle types to meet net zero, and to meet that energy demand, we'll need both low carbon and renewable gases, hydrogen, biomethane, but used in combination with low carbon electricity. And we also need carbon capture, utilization and storage, and also energy efficiency measures rolled out from production to appliances. On that pathway, our shared high-level pathway, we achieve net zero right across the UK economy. So that's in buildings, in industry, in power, and in transport. And as well as illustrating what that net zero system looks like when we reach net zero, what we wanted from this pathway is to sort of plot the course to take us to that endpoint. And this is really the work the networks are underway with, and you'll hear about more today, how we are making progress on that pathway to 2050. So I'm not going to take you through the overall high-level pathway that we have. You can see the full study of that on ENA's website. But I did want to focus in on the hydrogen strip that you can see on the chart there. So transitioning the gas networks to hydrogen really allows it to play a full role in the wider economy. And our plan for a hydrogen network transformation has 4 broad stages. So the first stage in the early 2020s, this sees the networks preparing for the energy transition, and that's including continuing their work on the Iron Mains risk reduction program to replace old pipes in the ground with new polyethylene pipes that are ready to transport hydrogen. The networks also in this first stage will complete the safety case for hydrogen and trial 100% hydrogen in homes. And that first stage is really crucial to give the government the information required to enable them to make policy decisions on the future role of gas in that net zero energy system. The second stage from 2025 to 2030, that sees the networks carrying out pilots, so larger 100% hydrogen domestic pilots. And also during this period, blends of up to 20% hydrogen will really be rolled out across the networks. Then in the 2030s, we'll scale up. So hydrogen pipelines will connect industrial clusters, and the country will convert to 100% hydrogen for use in homes in some parts of the country. And as this hydrogen network grows, industry not in those clusters and gas transport can also make use of that growing network. And then in the 2040s, and up to the 2040s, the full transition will occur. So we have this national hydrogen network in place throughout much of the country, and we can take advantage of the benefits that it brings. I won't talk through the detail on this slide. You'll hear much more about the projects here from each of the network representatives throughout the morning, but I wanted to illustrate here how the networks are working together to share their knowledge and their expertise, with learning from these different projects informing and shaping those that come after it. And then I think what's my final slide next up is really that I just wanted to sort of move from that top-down view of things to the individual level, so whether that's the household or how it impacts the individual. Many of the projects that the networks we'll discuss today and that they're working on is work relating to safety, establishing the safety case of hydrogen. And this is really vital to make the case for the role of hydrogen overall in society and for its wider acceptance. And projects are assessing whether using hydrogen in the natural gas grid is fundamentally safe, and many other projects are also looking at cost impacts, how much extra might bills be, but actually how much cheaper might they be than alternatives to this net zero hydrogen pathway the gas networks are supporting. And as well as looking at costs and safety, the networks are also looking at the benefits of a hydrogen economy. So if the UK does transition to a hydrogen-based energy future, what sort of investment will that unlock and bring into the UK, and what additional jobs could it create? So that's the Gas Goes Green view of how we transition to hydrogen networks and on the importance such a transformation has for net zero. I hope that sort of set the scene for the morning and teed up the networks to introduce some of their important projects they have underway. Andrew, I think I'll pass back to you.
Thanks very much, Tom. That gives an excellent introduction, as you say, to the issues that we are discussing, and perfect hand across to the network operators. And first network operator is Cadent, who I'll introduce very soon. Thanks again, Tom. As I say, first network operator, I'd like to welcome James Whitmore from Cadent, who's going to talk about two projects, High Deploy and HighNet, that Cadent are leading on currently. James, over to you. Thanks.
So morning, everybody. I'm James Whitmore, and I am the Future of Gas Innovation Manager for Cadent. And today I'm going to talk to you around two of our projects. One is High Deploy, which we're working in collaboration with Northern Gas Networks on, and that is looking to introduce a 20% blend of hydrogen into the gas networks safely without any change to existing infrastructure and appliances. And the other one is HighNet, which is a hydrogen and production and use carbon capture and storage industrial cluster looking to decarbonise the northwest region of the UK. So if I start with a bit around Cadent. So Cadent own and operate 4 of the 8 gas distribution networks. We provide gas to around 11 million customers in the UK. We have a hell of a lot of pipelines in the ground that we own and operate, and we transport the gas from the national transmission system to individual premises. We're a regulated business, so Ofgem requires us to do 2 things primarily, and that's provide a safe and reliable gas supply, and the other is emergency response. And we have lots of other regulatory requirements, but one of our main focuses is now, as we transition to net zero, is playing a key role with the other networks to develop what that transition looks like and prove the safety case for hydrogen in natural gas and 100% hydrogen as we move to net zero. So hydrogen blending. So initially I want to talk to you around the High Deploy project. So as I mentioned, this is a partnership between Cadent and Northern Gas Networks and other consortium members looking to prove that we can blend 20% hydrogen into the gas grid without any major changes. Now, natural gas is primarily made up of methane, which is a carbon-based fuel. So when you burn any natural gas, carbon dioxide is emitted. So, and on the other hand, when you burn hydrogen, the only product emitted is water. So the end game to fully decarbonise will be to reach 100% hydrogen in place of natural gas within the gas grid. So that asks the question, so why hydrogen blending? So why do we see hydrogen blending important is that hydrogen blending can take place without no or very minimal impact to the existing systems. So most appliances that we know of today, definitely in the domestic region, can take a 20% blend of hydrogen without any change. And we're working on proving the evidence base for the network and for the industrial and commercial appliances as we move forward to prove that case also. And by blending 20% hydrogen, it's a meaningful CO2 reduction in its own right. And so by introducing 20% hydrogen into the natural gas stream is the equivalent of taking 2.5 million cars off of the road. Also, we don't have huge hydrogen production capability in the UK yet. So to start with a 20% blending hydrogen into the grid with minimal change provides a demand for hydrogen production and enables business cases to be produced. It also helps us to establish a position with the Health and Safety Executive and prove the safety case for hydrogen. Supply chain and development, it eases the customers into the gas transition as well, into hydrogen. So it's a step in the right direction to 100%, and it should support the development of all of the 100% hydrogen networks in the future. So how do we do this? So in 2017, we started the High Deploy project, and today that's been a trial on a private isolated network in Keele University campus. So Keele are a project partner in the consortium, as are the HSE, Northern Gas Networks, Cadent, ITM Power and Progressive Energy. And we've been blending into Keele University now since October 2019. And the second part of the programme is to blend into a public network in the northeast of England, and that will be in Northern Gas Networks region. And that's another step. So it's gone from private network of circa 100 homes to a public network with a mixture of different homes and pipework materials, etc. And then the third part of the programme will look to clear any remaining evidence gaps that we haven't proven already, including the industrial and commercial users. And then that will predicate the rollout mechanism across the country. And all of this is in line with the 10-point plan and the government initiatives that Tom spoken around at the start of the presentation. So if we think about Keele University and where we started from, so the gas safety management regulations permit 0.1% hydrogen by volume in the gas stream. So to enable us to blend 20%, we need to prove a safety case that we can safely blend 20% to gain an exemption to those regulations. And what that safety case looks at is the materials that are transporting the gas, the assets, the procedures that are used to operate them, the gas characteristics, the appliances, the meters, etc., etc. And we then gained the first ever exemption to allow a 20% blend in the natural gas stream. So as I said, Keele has now been blending since October 2019, and the trial is successfully just finished this month. But the step to get there was, once we got the exemption in place, the installation can then take place. So the electrolyzer was installed, which produced hydrogen from water, and then the trial began and successfully blended. Whilst we operated the trial, we did a number of other things, which one, for example, was we partnered with the major boiler manufacturers. So your Worcester, Baxi, Valent, Ideal, and we installed 2 of each boilers on and ran them, one on the natural gas and one on a 20% blend. And at the end of the trial, they'll be removed, and the boiler manufacturers will take those apart and interrogate the boilers basically, and see if they can tell which one was on a blend and which one was on natural gas. But both have operated as you'd expect. So then, following the successful demonstration at Keele, we're now about to move into the public demonstration in the Northern Gas Networks region in the northeast, and this is at Winlayton in Gateshead. Now, this will be the first ever public demonstration of a 20% blend of hydrogen and natural gas, and this will include several businesses and non-domestic properties, and there'll be 688 premises in total. The gas network's managed by Northern Gas Networks, and as I said, it's the first public network that will accept a blend. There's ongoing stakeholder and community engagement going on in the area, and a lot of social acceptance work being carried out by Northern Gas Networks. So the trial is due to commence in the next month or so, and we're currently working with the HSE to gain the exemption to begin the trial. And then, following the trial in Northern Gas Networks, we then look to move to stage 3, which is then clearing all of the evidence gaps to be able to blend at network-wide scale, basically, between now and 2020-23. So that's what we'll be working on over the next 2 years, and that will lead to a pilot, which will then predicate rollout. One important thing to note, which is great news from this week, is that GasSafe have just issued a technical bulletin which states that there's no change required to domestic procedures when working on a 20% blend. So that's a huge milestone for the project, and what that means is that the 130,000 plus GasSafe installers that are out there working today won't need to be retrained to work in the domestic setting when operating a gas network with a blend. So further work's required in the industrial and commercial setting, as I said before, but that's a huge milestone for the domestic setting. So that leads us on to the HyNet project. So the HyNet project is a full chain hydrogen production and use industrial cluster with carbon capture and storage. And this is being led by a consortium of members. So we've got Progressive Energy, who are leading the development of the low carbon hydrogen production plant and CO2 pipeline. Cadent, so we're involved in the hydrogen infrastructure. We've got ENI, who are looking at carbon storage offshore. University of Chester, we've got Hanson Cement, SR Refinery, Innovin, and CF Fertilizers. And the HyNet consortium, you may have seen in the news this week, was awarded £72 million funding via the UK RI fund, and 33 million injected by the consortium members. And what this funding will do will allow the HyNet Northwest Consortium to accelerate to its final investment decision in 2023 for the initial phase to begin in 2025. This is a schematic of the HyNet Northwest region. So hydrogen production will be built at Ellesmere Port, and this will be via a autothermal reformer. So natural gas will be the feedstock, and the autothermal reformation plant will separate the natural gas into hydrogen and carbon dioxide. The hydrogen will be piped to local industrial users as a clean energy source, and the CO2 will be captured and transported offshore via a repurposed CO2 pipeline and safely stored in depleted gas fields. We'll then take the 100% hydrogen network further and blend it into the network at 20%. And this is where the work that HyDeploy comes in that I've just spoken around to supply millions of homes in the Manchester and Liverpool region. And this aligns with the net zero goals of both Manchester and Liverpool local authorities in those areas. And then we'll use the existing pipeline and offshore rig infrastructure for the CO2 storage, creating extendable CCS infrastructure. From 2025, HyNet Northwest will begin to convert natural gas into low carbon hydrogen and start to store carbon dioxide from users in that area into the Liverpool gas fields. And then by 2030, carbon dioxide emissions up to 10 million tonnes per year will be removed via the HyNet. And HyNet Northwest alone will already be delivering 80% of the government's new UK-wide target of 5 gigawatt production power by 2030. So this just gives you an idea of the phases of HyNet. So the first phase is the phase we're in now, which is working towards the final investment decision in 2023. Phase 2 is delivery of the hydrogen infrastructure and supply hydrogen to industry. Also, the carbon capture storage will be operational and will begin to blend natural gas into homes. And this will account for around 1 million tonnes of CO2 captured and stored every year. And then in phase 3, so we're looking 2027 onwards into the mid-2030s, hydrogen supply will be extended to the wider geography and to flexible power and to transport. And just to finally wrap up, so just to give you a flavour of some of the projects Cadent have been involved in, looking to understand the role for hydrogen and transport as we move to net zero. So High Motion is a piece of work which we did that has produced a roadmap for hydrogen in transport in the northwest around the HyNet region. We've done a lot of work in biomethane and bio-CNG and already have connected stations to our networks where trucks come and fill up with biomethane and compressed natural gas. We've got a future of gas transport pathways, which is looking to continue that work in the bio-CNG space and how that transitions to hydrogen. And then there's various other pieces of work looking at the impacts of blends on CNG engines, what the well-to-wheel emissions look like for hydrogen and hydrogen purity requirements. And also we were involved in a national grid project on hydrogen deblending. So that's it from me this morning. So thanks for listening. Appreciate your time, and I'll pass back to Andrew.
Thanks a lot, James. Thank you very much for being with us this morning and sharing that information. Really, really useful. Some questions are coming through, but I think we'll still try and leave those until the end if that's okay. But Stella, thanks for being with us. You're from Northern Gas Networks and you've joined us to talk about H21 and the hydrogen home as well. So as I say, it'd be really interesting to get some information in terms of how we're heading to use of 100% hydrogen in the future. Over to you, Stella. Thanks.
Good morning, everyone. I'm Stella Matthews, Hydrogen Development Manager at Northern Gas Networks. Just a quick introduction to Northern Gas Networks. We're one of the gas distribution networks. We cover the north of England, and all of the areas that you can see on the screen are what we specifically manage. I'm here today to talk to you about the H21 and Hydrogen Home. So H21 is a programme of projects which is seeking to demonstrate the suitability of the existing natural gas infrastructure to distribute 100% hydrogen. So if we go right to the beginning, H21 actually started back in 2016, and it was a feasibility study that Northern Gas Networks produced, and it took the blueprint of the City of Leeds and looked at, if we were to convert the City of Leeds to 100% hydrogen, is it technologically possible and is it economically feasible? And we found that it was on both counts. This then led to ourselves, along with all the other gas distribution networks, so that's Cadent, SGN and Wales and West, applying for funding from the Network Innovation Competition, which is a funding stream that Ofgem run. And we were successful and received some funding to deliver phase 1 in 2017. In 2019, we submitted a funding bid for another second round of funding to deliver phase 2, and that was awarded in 2019, and we were joined by National Grid at that point. So if we look at the phase 1 of the project, phase 1, we also had project partners in addition to the gas distribution networks with the HSE Science Division and DMVGL. And phase 1 was really looking at answering specific questions on both leakage. So if we get any leakage on the network, as we do sometimes, will hydrogen leak more, with it being a third of the energy value? So we constructed a purpose-built testing facility at HSE's site at Buxton, and we took pipes from around the network that were being replaced as part of our iron mains replacement programme. We filled them with methane and observed the leakage rate, and then we filled them again with hydrogen to observe the leakage rate. We then went one step further at DMVGL's Spade Adams site, and we looked at, so if we do get leakage on the network from hydrogen, what are the consequences of that leakage? So how does it track and disperse? What is the ignition point? How much hydrogen is required to collect to ignite? And what is its explosive limit? So the results of those pieces of work are due to be released in the next couple of months, and they will be launched via a special ENA webinar. So I would advise anyone who's interested in that research to go along to that. We're now working on phase 2, again with all the gas distribution networks, National Grid, and also DMVGL and HSE Science Division. And we're specifically looking at, as a gas distribution network, if we convert to 100% hydrogen, can we maintain and operate that network as safe as we do today? Can we use the same processes and procedures that we have in place today? So the HSE Science Division have looked at our entire set of procedures, and they've identified the ones that may need further investigation to see if hydrogen will be a problem in any way and require any amendment to those particular procedures. So in order to test those procedures, again at DMVGL's Spade Adams site, we've constructed a microgrid, which is basically a mini version of our network, including all the different pressure tiers. And we're going to fill that with hydrogen and then conduct some of those procedures that we do every day to see if there is any effect on that particular network. We're then going one step further later on this year, and we've identified a part of our network that is still connected to the large network. There's no end users on that particular part of the network, and we have isolated it. We're going to convert it to 100% hydrogen, so it currently holds natural gas, and it will be the first part of the UK network to be converted to hydrogen. And then we're going to replicate a lot of those procedures that we're testing up at the Spade Adams site, purely because the pipes that we're going to be converting to hydrogen have been in the ground for a long time. So there may be some issues that crop up that we're not aware of. So we want to test it in situ and also bring it out into the public and make the public more aware of what we're trying to do. Ultimately, what we're working towards is a live trial, which is our phase 3. We're hoping to convert 50 homes by the middle of next year to 100% hydrogen. These will all be with end users. Unlike the 20% blend, 100% hydrogen will require you to swap out your boilers and any gas appliances for 100% hydrogen ready appliances. So that's something that we want to see how that works, look at the timing of conversion and how long people might have to be off gas and whether that is acceptable to customers. We'll then go one step further after the initial 50 homes and convert the remaining 620 a year after that. As part of this project, we're going to look at production and storage and how that will work and how that will feed into the network, and obviously the new appliances that will be required. Another piece of work that kind of underpins everything that we've done, we can look at all the engineering, and that's fantastic. Unfortunately, if customers don't want to go or don't want to use hydrogen or don't see it as being something that they're comfortable having in the home, we can do all the engineering we like, but it's never going to get off the ground. So we did a piece of social science research with Leeds Beckett University, and we looked specifically at public perceptions of having hydrogen or converting to hydrogen. And we found that we thought safety would be a major issue as a gas distribution network. And we found that actually the public trust the gas distribution companies and trust that they wouldn't put anything that's unsafe into their homes, which is testament to how well we run the network. But cost is a huge barrier. both of rising bills and of having to pay for new appliances and disruption to your home or around your local area. We also found that there is some ability to digest a lot of this technical information, but we're guilty of using acronyms in this industry, and we need to kind of stay away from that. And the public want to be brought on this journey with us. So we're starting that journey now with them, and we're developing communication materials specifically talking about the conversion and what they can expect when conversion happens. We also have a suite of what we call Network Innovation Allowance funded projects, and these are looking at all the little gaps that we've got. So we're looking at the big issues in the network innovation competition phase parts of the project, but we're also looking at the other gaps that haven't been covered in those pieces, and that includes looking at compatibility of services with hydrogen, compatibility of components on the network, because while we talk about the assets, we very much usually mean the pipelines in that. There's lots of other different components, valves, etc., that we need to check are going to be compatible with hydrogen. We also looked at our industrial and commercial customers and how we may start to convert them, and look at how we will get that initial hydrogen supply to the places that we want to start converting in. And the last thing I want to talk about today, as I've mentioned, appliances will need to be changed for 100% hydrogen. And we've actually teamed up with Cadent and the BASE Hy4Heat project. So Hy4Heat have developed hydrogen-ready boilers and other appliances and hydrogen-ready meters. And what we've done is built a pair of typical semi-detached houses. They're actually constructed at our Low-Thornley site at Gateshead. And we're going to install 100% appliances into those homes and run them on hydrogen. And that will be open for any member of the public, any stakeholder, to go and visit and become familiar with those appliances and see that they look and feel very much the same as your current gas appliances. And it's also to demonstrate to policymakers that there is some potential in hydrogen and that this is something that we can achieve now and not just in the future. So that's everything from me. Thank you for your time, and I shall hand back over.
Thank you very much, Stella. Thanks again for joining us today. Yeah, I'm going to hand straight across now to Joe Mitchell from SGN, who's going to talk about a 100% project based in Fife, which delivers green hydrogen test, the transmission, distribution and use of green hydrogen in homes. So Joe, over to you. Thank you very much.
So yeah, hi everybody. I'm Joe Mitchell. I'm a project officer in SGN's Energy Futures Department. So we work on our decarbonisation projects. So as a bit of background, SGN is one of Britain's 4 gas distribution networks, delivering gas to almost 6 million customer connections across Scotland and Southern England. So yeah, I'm going to be talking about our H100 Fife project. So with this project, we're developing a world's first hydrogen network in Leavenmouth in Fife. So this will bring 100% renewable hydrogen into homes in 2022, providing zero carbon fuel for heating and cooking. We've just got a bit of a graphic showing the kind of end-to-end system that we've got planned. So yeah, in this project's first phase, the network will heat around 300 local homes using hydrogen produced by a dedicated electrolysis plant, which is powered by a nearby offshore wind turbine. The project is the first of its kind to employ a supply of clean power to produce hydrogen for domestic heating. So the system will be designed and built to ensure the same high safety and reliability standards that are expected from our current gas system. And an on-site storage unit will hold enough hydrogen to ensure supply won't be disrupted even during the coldest weather conditions. So yeah, this just shows the site. So this is Leavenmouth in Fife. It's home to the town of Methil, and it offers a location that's unique for demonstrating hydrogen as an energy carrier. So it provides access to an existing 7 megawatt offshore wind turbine, which is owned by the Offshore Renewable Energy Catapult. And it's also next to a vacant slot owned by Scottish Enterprise. And that's development land for energy activities. So this site, identified for hydrogen production and storage facility, as well as a demonstration facility, is located adjacent to potential domestic end users. So this picture just shows the demo facility to be constructed in April 2022. So one of the key benefits of this project is the insight that it will provide into customer appetite and interest towards hydrogen and low carbon heating solutions. it'll give the people in Leavenworth the opportunity to be at the forefront of research into hydrogen heating systems. So eligible households can participate on an opt-in basis, meaning they'll have the choice to switch to hydrogen or remain on their existing natural gas supply. So the proposed demonstration facility will allow customers to see and experience hydrogen appliances in a home-like setting before opting in. So yeah, once it's up and running, we'll be able to measure the technical, social, and commercial performance of the world's first 100% hydrogen network. Yeah, so this just gives an idea of the participation process for customers. So customers are invited into SGN's demonstration facility on site. And with this, they'll be able to interact with the hydrogen appliances, experience central heating, hot water, cooking, fireplaces, all provided by hydrogen. And there'll be opportunities for people to meet the team, ask key questions, and get a bit more comfortable with it. The properties able to connect will be identified and invited to participate in our project. And then we'll visit all the customers signing up to the project to complete all the necessary internal property checks and verify their participation. SGN will then arrange customer homeworks to replace all the natural gas appliances with comparable hydrogen gas versions and connect to the new hydrogen supply. Throughout the project, the customers will have support and 24-hour call out available throughout the duration of the project. Yeah, so these just show the boilers. Yeah, I think as already been discussed, hydrogen boilers cost around the same as current versions and can be adjusted for hydrogen just in under an hour. But with this project, the initial 300 customers joining the project will receive a free hydrogen connection, free replacement hydrogen appliances, and maintenance over the length of the project. And as well as that, they'll pay the same amount for hydrogen gas as they would for natural gas. So we've also agreed partnerships with High Cookers and High Fires. And they'll be equipping each show home with the relevant hydrogen fires and cooking appliances, just showing that UK and SGN are at the forefront of decarbonising domestic cooking and heating. Yeah, so yeah, this just gives an overview of the timeline. So plans for the project have been approved by Ofgem, and yeah, pending local partner approval, we'll be ready for construction to begin later this year. We'll be keeping the community in Leavenworth informed throughout development, and customers will be invited to the hydrogen demonstration facility in 2022, ahead of the project going live later that year. The project will be operational for 4.5 years until March 2027. So yeah, just in terms of future expansion opportunities, as we discussed, phase 1 of the project will cover the 300 homes in this new network. In phase 2, we'll look to expand upon that, including conversion of existing natural gas customers within that area. In phase 3, we'll look to expand this project to include some of our industrial and commercial meter points in that area. So this includes local distilleries, a water treatment facility, and various manufacturers. So in phase 4, we're more looking at transport. So this will include road, rail, marine transport over a larger area. So this includes a potential hydrogen rail rink, hydrogen-powered haulage. As the site is located next to a marine port, there's also the prospect for marine hydrogen transport or hydrogen-powered vessels. And then phase 5 will be expanding further, looking at fully integrating with the power network to provide energy storage, heating, and transport decarbonisation options. So this just fits in with a wider range of projects aimed at decarbonising the gas network, a lot of them based down the east coast of Scotland. This image just shows the project site just from a slightly different angle. Currently, the project has quite a small footprint, but as you can see, just at the bottom of the picture there's a lot of space that's been designated as development land for energy activities. So yeah, a lot of room for expansion with the project. Yeah, so this image on the right just shows some of our decarbonisation projects that we've got ongoing and coming up in our upcoming price control. And yeah, on the right hand side, it shows just the hydrogen kind of east coast. The northeast coast of Scotland has potential to become a major hydrogen hub thanks to its existing infrastructure and clustering of major carbon emitters, as well as the proximity to storage capacity for sequestered carbon dioxide, and also the onshore and offshore renewable energy resources. So with its abundant renewable resources and the early promise shown by the carbon capture storage projects, Scotland's east coast is in a really strong position to seize this opportunity and become a leader in hydrogen. I think that's all the slides from me. So yeah, thanks for your time, and yeah, I'll pass back to Andrew.
Thank you very much, Joe. That was great finding out more about the kind of holy grail, if you like, isn't it? The complete 100% green hydrogen being used at scale in the future, not just in homes, but in various industrial sites and industrial applications. So thank you very much for that. I'm going to pass straight across now to Ollie Lancaster from Wales and West Utilities. He's going to talk about hybrid heating systems and optimizing retrofit as well, importantly, in homes and other aspects of the built environment. So Ollie, welcome.
Thanks, Lewis. We're, as Andrew just said, Wales and West Utilities, one of the gas distribution system operators in GB. And just for awareness, really, from a future of energy perspective, a bit of an introduction here. We provide almost 60 gigawatt hours of energy storage in just our network each day. So that's the equivalent of 6 million Tesla Powerwalls. We have a number of renewable gas sites or biomethane sites connected that's enough to heat 150,000 homes, which is actually enough for 750,000 hybrid heated homes, which I'll come on to shortly. More and more power stations are connecting to enable renewable generation, so backfilling for when the wind doesn't blow and the sun doesn't shine, and for when there's peak demand times. We've got a lot of industry connected, as been mentioned before in some of the other presentations. We've got steel making as part of the South Wales Industrial Cluster in our area, and more vehicle connections, so 4 at the moment for buses and trucks, and they're growing in number too. This is just a quick at what the energy system is a bit like today, and it's getting more integrated than this. It used to be completely separate gas and electricity networks, but it's becoming more integrated on multi-vector, you may have heard about, and hybrid heating systems are a part of this energy system integration that happens in the building level between electricity and gas. And so just quickly touching on what a hybrid heating system is, this is where on the right hand side you'll just see there, it's a small air source heat pump that is plumbed in and retrofitted to a building that's already got a wet heating system in it with a boiler. It doesn't have to have a hot water cylinder, that's optional. But what's important here is to recognise that there are no prerequisites to this being installed. This can just be put into a building taking it as it is. So it doesn't need to have insulation measures retrofitted for a low temperature heating system, doesn't need to have bigger radiators or larger pipe work or anything like that. It just takes the building, as I say, as it is. And it actually self-learns the thermal dynamics of the building, these smart systems, so that you're able to essentially diagnose what the economic fabric retrofit activities are to do afterwards, which kind of pushes back against a bit the fabric first principle, albeit there definitely needs to be energy efficiency measures applied. But in putting the technology in first, you can self-diagnose what's economic and what can be done. So it's a fairly easy retrofit, and it's pretty low regrets. It maintains the flexibility of both networks as policy is developed further. It optimizes both for the building occupier, the household, the consumer, and the energy system. So it switches. What's important here is that you can get hybrid systems at the moment that aren't all that clever. They aren't grid connected. They can't receive grid signals. So this that's been tested and been deployed and is available commercially at the moment is smart, so that it can respond to grid signals. So we have signals that come in on cost. So that could be on flat electricity tariffs and looking at the fuel price ratio between gas and electricity. Interestingly there, if you have a dynamic tariff like Octopus Agile, then it brings the heat pump into competition against the boiler quite a bit more of the time of the day. It narrows that fuel price ratio difference. It can switch on carbon as well. So whichever is the lowest cost vector, whichever is the lowest cost appliance for delivery of the heat demand. And clearly, ultimately, this will be a case of switching between renewable power when it's available and green gas at other times, or when it's very cold, that being hydrogen for lots of GB and some parts that may remain on a biomethane network. It can overcome grid constraints, so avoiding the overwhelming of a substation and its sub-network with demand being too high, so taking some demand off helping to manage that constraint, and other flexibility value as well, coming from the likes of fast frequency response. So this is actually it's the highest value fast frequency response you can get, because you can take off an aggregated demand, all the electricity demand of the heat pump within seconds, and transfer the demand all onto the boiler without any discomfort for the household or occupier, for as long as is needed until that constraint is lifted. So that can help avoid blackouts in the heating season. It works with existing gas and electricity networks as they are. It works both on and off the gas grid. So a number of the homes in the Freedom Project used hybrids with LPG, and they were really successful and saved a lot of money. And it uses the gas network essentially as the flexibility and storage asset to enable this to happen, balancing between when renewables are available and when they're not, and being there for when it's the hard working days of the heating season, when it's very cold. And perhaps controversially, it's lower carbon than a heat pump alone, because this isn't just looking at the emissions around the building on its own, so building regs style approach to emissions. This is looking at the whole energy system emissions and avoiding upstreaming more emissions to the power sector than are saved at the building sector. And a lot of the cost savings that this approach gives you is in the avoidance of investment in different parts of the energy system, in buildings, so avoiding over retrofitting buildings, avoiding overbuilding electricity generation, that's overbuilding too much underutilized low carbon generation and backup generation, and avoiding over reinforcing with the electricity network. Clearly it needs reinforcement, but helping to optimize that. This box here, in a bit of a Committee on Climate Change kind of way, just shows what the carbon is in heating at the moment, and how this can be overcome. So some areas will be suitable for heat networks where you've got a long-term low carbon heat source that's co-located with a density of demand, and other areas off the gas grid that may not be connecting to the gas grid will have other solutions. And then there's a degree of energy efficiency to be applied to buildings, and about 12 to 15% is the economic level of energy efficiency, up to 20% is beyond the economic, but where you get further well-being benefits as well. And then you've got on gas grid, and what do you do with that? Well, areas that are on hydrogen, not necessarily an equal split here between hydrogen and biomethane, but areas on hydrogen, using hydrogen boilers and using wind that works well in winter as a renewable through the heat pump. And then on the right-hand side there, you've got an example of a biomethane area where you've delivered some energy efficiency, and then the hybrid is working on an 80-20 basis between the heat pump and the boiler. And actually, we've got parts of our network already that have got enough biomethane flowing through the network all year that they are a hybrid ready area. There's enough biomethane flowing for hybrid heating systems in those areas, such as the town of Wrexham and the Vale-of-Evesham part of our southwest network. And hydrogen hybrids, we've been thinking a lot about those, especially around looking at the South Wales industrial cluster. So we've been looking at a regional hydrogen supply for South Wales in working at the South Wales Hydrogen Superplace. So like HyNet was presented just before, this is the equivalent down in South Wales, where we're working to deliver the infrastructure to connect up hydrogen supply and industry, but also then it provides the opportunity for hydrogen spread into a superplace so that it's available for wider sectors for power, transport and heating homes. And one of the benefits of hybrids with hydrogen is on the production side. So where you've got blue hydrogen production, it can actually help a great deal with the CO2 logistics, the CCS. So it helps to reduce any constraints and logistics around the export, which would need to be from South Wales, of shipping of carbon dioxide to the likes of where HyNet is proposing to store the carbon dioxide, or other places, other destinations for the carbon dioxide, and a whole host of other reasons why there are benefits to it, but in helping us to develop what the least cost approach is and least cumulative carbon approach is to decarbonisation of home heating. This is a next generation hybrid. So the Freedom Project hybrid was an external air source heat pump with an internal boiler, and this is a high compact one, so where there's a 4 kilowatt heat pump inside the boiler unit. We're doing this project at the moment with the support of all the other gas distribution networks and in partnership with another electricity network. And this is a low-cost solution in one box. It's pretty low disruption, no outside space is taken. But one of the significant things here is it overcomes pretty big skills challenge with retrofit. in that the existing stock of gas engineers and gas boiler installers that do 1.7 million of these a year can install heat pumps as well, because the heat pump in these is installed in the manufacturing process. And if we take our business plan that we submitted to Ofgem and we consider that ambition to be net zero ready by 2035 and policy coming in line with what our ambitious net zero plan is, the graph on the right hand side shows what the average carbon intensity of gas in our network looks like all the way to 2050 or 2051, because it goes by regulatory price controls as 5 years. And that's achieved from a number of things. And that's increasing biomethane entry now, operating a smart gas grid, including compression to enable the more use and bringing on of more biomethane into the grid, blending of hydrogen in North Wales and South Wales and other parts of our network, industrial fuel switching, and wider areas, wider regions switching over to 100% hydrogen as well. But the help given in decarbonising as quickly as possible is given by putting hydro heating systems in as a rollout as soon as possible. So in the 2020s, until we get significant conversion over to 100% hydrogen, a lot of the action we can be delivering is in hybrids and biomethane and hydrogen blends. Thank you very much for listening.
Thank you very much, Ollie. Thanks for that. I think we'll just invite Lloyd from National Grid Gas Transmission to give his presentation. Lloyd, welcome. You're going to talk obviously about developing hydrogen distribution within the national gas transmission system. So thanks for being with us this morning. Over to you.
Yep, thanks, Andrew. My name's Lloyd Mitchell. I'm the hydrogen engineering lead for the Future Grid project at National Grid. So for quick context, we, as National Grid Gas Transmission, we sit upstream of the distribution networks. So we operate the high pressure system, which connects the terminals around the country to the distribution networks. That's about 7,500 kilometres of high pressure gas network. So we've wrapped our hydrogen projects under the HINTS programme. So here's just an example of a few of the things we've been looking at around hydrogen. So we've done a desktop study into the feasibility of using hydrogen on the gas network, looking at the effects on materials within the network. We looked at some regional case studies. So for example, Project Cavendish, which looked at using the Isle of Grain in Kent to decarbonise London and the South East. We've looked at Northern Scotland in the Aberdeen Vision project, looking at how the St Fergus gas terminal can be used to decarbonise Scotland and Aberdeen in particular. We've looked at hydrogen deblending, as some of the distribution networks I've mentioned earlier on. And we've also compared some of the existing pipes that we have, so X52 pipeline steels, to new pipeline methods for potential further expansion of the network if necessary. So an important part of what we've been doing is looking at how we link up the hydrogen supply to the hydrogen demand across the country. So across Europe, there was a project called the European Hydrogen Backbone. It was undertaken last year, looking at how that might look within Europe. It involved 11 transmission system operators across Europe, and it was looking at a total network length of 23,000 kilometres by 2040 to connect up all their systems. And that would be 75% converting the existing network and 25% new build pipes. And the expected cost for that was between 27 and 64 billion euros. So looking at that, we've tried to take that over to the UK and look at how best we could connect up the major regional clusters within the UK. So the image on the left shows us a very initial view of what that could look like, and that is being developed under Project Union, which will flesh out what this sort of hydrogen backbone through the UK could look like. So just briefly looking at a timeline of what the National Grid view of hydrogen is going out to 2050. So we're looking at, in this year, in fact, the Future Grid programme, which I'll talk about in a second, is kicking off, and that's taking existing assets and building a sort of mock network. 2023, we're looking at potential online trials, depending on whether there are willing customers out there. 2026, hoping for a conversion plan based off Project Union to be complete, and then looking out to 25, hoping to be able to enable sort of the import and export of hydrogen in the UK through our interconnectors, which link us into Europe via Belgium, France, and the Netherlands. The facility is essentially going to be taking existing assets that have been decommissioned from the rest of the network, bringing them up to DNV's site at Spade Adam in Cumbria, bolting them, welding them together, and then operating them on hydrogen as a view of how all these assets, how the network at large will operate hydrogen. And it's also going to be linked into H21's High Street project. And essentially what that is what we call a beach to burner demonstration of hydrogen. So it's a very condensed version of the entire UK network on one site, which is going to be very useful for proving the case for hydrogen. So this is a mock-up of what it might look like. So we're taking assets from various places across the network. So we've got assets from entry points, got a block valve, we've got an exit point, and all of these are sort of maybe 20, 30-year-old assets that we're taking from various places around the network, and that are going to be a really good representation of the real life network. So we're not getting a load of new equipment. We need to ensure that it is representative. So phase one is looking at 3 different main concentrations. So we will baseline the facility on natural gas. We'll then look at 2% hydrogen, 20% hydrogen, and 100% hydrogen to see how it performs at those different percentages. This will be operated for 6 to 12 months, and we will gather all the information and collate it, and all the information will be publicly shared. And we're also collaborating with some European transmission system operators to compare results. The final phase of the project is going to be taking all the findings that we've generated through the work and developing those into a real risk assessment of the way the risks differ with hydrogen, because although it is a very similar gas in principle, it's explosive, flammable, odorless gas, there are some unique risks associated with hydrogen, and we need to understand how we're going to manage those within the national transmission system. So that was phase one of Future Grid. Phase two is going to be looking at how we take this further. So looking at potentially how deblending could operate within the network, and also looking at compression, because we have 24 compressors across the NTS which push gas around the country, and there's going to be quite a big difference in how they operate with hydrogen. So we need to understand that. There's phase three of the project, which is looking at how we bring in third parties who are interested in developing their own hydrogen capabilities, people like OEMs and other asset operators who can use our facility to test their own assets, and it will be a sort of collaborative space for hydrogen research. So that is my view of National Grid's work in hydrogen and the NTS. Thank you very much, and I'll pass back to Andrew for questions.
Lloyd, thanks again to everyone who's contributed this morning with some fascinating information about the macro view and also kind of the micro view in terms of technologies and trials and projects underway to use hydrogen in the home. So it's been a really good blend of information for everyone on the call. Thanks again. Let's try and go through some questions now, because there's so much information to take in. And if I could invite all our speakers to join me on a panel, let's see how this works. The first question was from Mariam Bishai regarding the kind of 2080 blend plus moves to 100% hydrogen in boilers. Mariam, I don't know if you want to give any more information around that, but we've obviously had some detail around future 100% boilers being available through this. Would any of our speakers like to talk more about the timing of that?
Yeah, I can do. So the boiler manufacturers have developed hydrogen-ready boilers as part of the BEIS Hyperheat program, and some of those are going into demonstrators at the moment. And then over the coming few years, we'll be moving from hundreds to thousands and tens of thousands of those available off the production line, then to full changeover of the production line by 2025 at the latest. So they're boilers that can burn natural gas today with the blend up to 20%, and then be very quickly within an hour have a changeover of just two small parts to be able to burn 100% hydrogen as and when their street is converted over.
Okay. So that's often seen as a barrier, but it's not in effect, is what you're saying. It can be scaled up very quickly, providing 100% hydrogen and transforming blended boilers to 100%.
Andrew, just to add to that, and I think there's a question around for confirmation, can current boilers operate on a 20% blend, and that's what the High Deploy project is proving the case of. So there'll be a transitionary period that existing boilers that we have today that are running on natural gas will be able to take a 20% blend with no change, and then as 100% hydrogen comes later down the line, we can That will require a replacement, but that's when the hydrogen ready boilers come in that will operate on a natural gas and or hydrogen blend, and then can be swapped to 100% hydrogen as and when the conversion happens.
Okay, thank you very much, James. There was also a question earlier around electrolysis, and obviously involved in production of green hydrogen. How much electrolysis was the question will be required for a 5 gigawatt target by 2013? I'm, assuming that it's not all going to be from electrolysis. The majority in the early days of the transformation will be from the greater scale of production of hydrogen, steam, methane reforming, etc. Is that right?
Just touching on the water part of that question, I didn't realise until recently, until exploring that with offshore floating wind electrolysis, that they've explained it to me as a simple message that it's one tap per turbine. So one flowing tap per turbine for the electrolysis and producing hydrogen. But yeah, as far as methane reforming goes, to get the scale needed for industrial fuel switching, at least there needs to be some significant deployment of methane reforming with CCS alongside development of green hydrogen too.
Would anyone else like to comment quickly on that?
I think just to agree with Ollie, I think initially to get the scale of hydrogen that's needed will be natural gas reformation with carbon capture and storage, and then the development of green hydrogen, electrolysis technologies as that develops, to be able to deliver greater scales, then more of that will increase.
Okay, thank you very much. There was another question earlier around off-grid. I guess in terms of delivering and transmitting hydrogen to off-grid areas of the country, is there any work underway around that agenda?
Yes, there is. Someone may, one of the other panelists may know more about a high-scale project than I do about transporting hydrogen in different forms for rural networks and rural use off the gas grid. But off-gas grid areas actually have a range of options. It doesn't just have to be full electrification with heat pumps, which is clearly a lot of fabric work to do as well at a significant cost. You could have bio-LPG hybrid systems, oil systems converting over to LPG with the same wet heating system. And you could have local circular economies of biomethane being produced from local waste into a local discrete network. Same for hydrogen, really. So there are plenty of opportunities for them.
Okay, thanks for that, Ollie. There's a question around central government hydrogen projects. Are there any central government hydrogen projects currently underway? I'm assuming the funding blend comes partly from central government for many of your projects, but would anyone like to speak around that issue? Tom, do you know if there's any purely centrally government funded hydrogen projects currently underway?
I think Hy4Heat's probably the hydrogen project where the government is most involved in driving it, but networks are working closely with government on a number of their own projects. The Hy4Heat project's looking more from the emergency control valve into the house. What's the impact of hydrogen there? And a lot of the testing and trialing is being done by network expertise to feed into that. But as you say, the government's support is on sort of creation of the mechanisms needed to support the commercials for hydrogen production and the wider economy growth.
Okay, thank you very much. There was a mention around the kind of relative efficiencies of hydrogen compared to methane, natural gas. Do any of the panelists want to talk around that, whether we can overcome that in any way, whether that is, how much is that as a barrier to transforming and wider scale adoption of hydrogen in the future?
Just wondered if it was worth the person who asked the question would like to explain a bit more about what they meant around the efficiencies. Was that efficiencies of production or use or other aspects?
Source of energy, I think. Feel free to join us, Mariam. The question was.
Yep.
Yeah,
Hi everyone. Yeah, so I was just asking about the use of hydrogen instead of fossil fuels and how efficient as a source of energy, because I've read some articles that we might have efficiency issues and resources issues as well, like the quantities we need. So that's what I was asking about.
Yeah, thank you.
Thanks for that. I think what that was referring to was the efficiencies of conversion of hydrogen from water with electrolysis, and quite often it's pointed that that's an inefficient process, and to have a fully green hydrogen system would need X gigawatt extra of capacity of generation. But when actually you look across all the options available, you look at all the costs in delivering a secure system using both sets of electricity and gas infrastructure. To go heavily down one side for everything, there's a great deal of inefficiency there. So on full electrification, a great deal of inefficiency in the underutilization of assets as well. And so efficiency is really important, but it's important to not just pick out one solution, one option for the future, to go down an efficiency route, I guess, and have a good thorough look across the whole energy system, what all the options are.
Just on this point, another kind of related question: is it true that electrolysis needs salt-free water? And the question there was, to grow the use of electrolysis, clearly we probably need desalination plants to operate in tandem with the use of seawater. So would any of the panelists like to talk about that?
I don't want anyone to get bored of my voice.
You've been very helpful.
No, sorry. So there's a lot of work going on around the electrolysis of seawater, and you might want to look at the Dolphin project, the RM Dolphin project with floating offshore wind, and that includes desalination and electrolysis on the turbine platform, and then delivery of hydrogen through pipe work to the shore, and so you'll be able to find out a great deal about that there. Also, there could be added value from long-term nuclear fleets in their use for electrolysis and hydrogen production. Most of those are located on the coast, and so you can have large-scale electrolysis and large-scale desalination, providing flexibility to a nuclear plant, essentially, so that in demand response and in response to live renewable generation, you could have large-scale electrolysis co-located with nuclear, which would need desalination as well. Or you could have electrolysis of brine and produce green chlorine, which has a global market.
Thank you very much. Just one quick final question. I realise we're almost out of time. Interesting questions just come in regarding storage issues around hydrogen. In terms of liquefaction of hydrogen, the understanding is that it takes a huge amount of energy relative to LNG. Would any one of the panelists like to comment on that in terms of whether we need to store huge amounts of hydrogen to make a successful transformation in the future? And if we do, what are the challenges around that?
I could comment on this one quickly, I suppose. So we've been looking at hydrogen in the context of managing the systems, the transmission system naturally. So hydrogen has around a third the energy density of gas. So at the moment we rely on the inherent storage capacity of the network itself, which gives us sort of a couple of days of buffer. That would be reduced with hydrogen. So we're confident a lot of that can be made up for in terms of properly managing the supply of hydrogen, because our network has already got quite a lot of flexibility in the moment. So, but there is still an element of we would need more storage. So there's projects going on looking at conversion of existing underground storage facilities, because we have a number in the UK based in salt caverns. So understanding how we can convert those to operate with hydrogen. And there's also some research going on into new methods of hydrogen storage. So there's a couple of projects that we're involved in looking at. There's one looking at bonding it into essentially a type of oil. So it's much more efficient than liquefying it simply by cooling. So that's quite an interesting project. And there's another one looking at whether there are ways of storing it in a sort of, I think it was called an interstitial matrix. So it's sort of like a lattice structure where the hydrogen adsorbs onto the surface of this material, and then you can take it back off when needed, and that's in a solid, so it's extremely dense. So there's quite a few different technologies we're looking at for potentially storing hydrogen. It's definitely something we need to address, but it's not one of the major concerns at the moment for us in terms of switching to hydrogen.
there's also a question around what scale of hydrogen storage would be needed as well. And so we've been doing a lot of detailed analysis around the cost optimization of hydrogen production capacity and load factor versus the amount of hydrogen storage you have. And so for a while, we've been looking at hydrogen production plants running on a flat basis, and then any hydrogen produced that doesn't have a demand at that time goes into storage. That needs more hydrogen storage. So we've been looking at lower load factors and higher capacity of these kind of plants. That was showing that the cost optimal was to have a larger capacity and lower load factor at about 60%, and only investing in more critical levels of hydrogen storage, which is actually very much like it used to be in town gas days. A lot of the storage being in the material being gasified, so coal in the ground as it was then, or for blue hydrogen gas in the ground, and then limiting the amount of product storage that you have, and operating the capacity of hydrogen production, as it was then, town gas production, flexibly to meet demand, so demand matching. So there's that element as well to defining what storage needs are.
I'm going to draw everything to a conclusion now. It's over, but it's such a fascinating subject. It's difficult to do it justice in 90 minutes, although we've tried to provide as much information as we can in that short space of time. It just remains for me to thank the speakers and contributors again. We really appreciate your time and sharing your expertise. So thanks, Ollie, thanks, Tom, Joe, Stella, James, and Lloyd. Everyone's very appreciative of you being able to join us this morning. And we'll probably try and repeat this type of webinar in the future, because hydrogen, it's clear, is here to stay, and it will only grow in terms of its use and scalability into the next few years. So I hope that's been informative. So thanks again. I look forward to seeing you again at the next Supply Chain School event. Bye for now. Thanks.